Now, this is the solution to the prism problem that I set last week. Now, you remember we had the problem with Frome Jail, which got closed down for reasons we'll understand in a few minutes. There were 50 cells with 50 prisoners, one prisoner per cell. And at the end of the day, the 50 prison wardens came along and they had a weird way of locking up. Prison warden number 1 would turn his key in every cell that was in the 1 times table. Prison warden 2 would do the 2 times table. Prison warden 3, the 3 times table, and so on. So we have this situation with the 1st, 2nd, 3rd, 4th, 5th, 6th. These are the cell numbers. Then the first one gets locked by the first warden, locked by the first one. These all get locked by the first one. The second one comes along, turns his key, but he has the effect of unlocking every number in the 2 times table. Third one comes along, well, he unlocks number 3 because he turns his key again, but he actually locks number 6. So 6 is locked up again, so that's good. But it looks like 2 and 3 are going to be free at the end of the night. When we get to cell number 4, warden number 4, he in fact locks up cell number 4. But if we had 8 here, this one would have been unlocked. He would actually lock up number 8 again. 5 would get unlocked. 6 would then get unlocked. 7 would get unlocked. 8 would then get unlocked as well. So of the first 8 prisoners, 2 have been locked up and 6 haven't. Now, what I'm going to do is take you to a bit of an extended version of this. Now, this is for the first 16 cells. The cells are numbered there. So, prison warden 1 locks everybody up. Prison warden number 2 unlocks the odd even numbers. Prison warden number 3, well, he unlocks, locks, unlocks, locks, unlocks. But we get this situation here. Now, if we take a look down here, we'll see the numbers that are locked up are 1, 4, 9, and 16. So if we go back to our previous sheet, we can say at the end of this problem, the ones that get locked up are 1, 4, 9, and 16. Now, what's special about this sequence? Well, there's a few things about this sequence. You may notice it goes up 3, it goes up 5, it goes up 7. If you continue this pattern, if we go up 9 to the next number, we get 25. These are also known as the square numbers. They're called square numbers because they make squares. We've got 1 there. If we add 3 on, we get 4. If we then add 5 on, we get 9. If we then add 7 on, we get 16, and so on. So 1 is 1 times 1, 4 is 2 times 2, 9 is 3 times 3, 16 is 4 times 4, and so on. But why are these people locked up at the end of the night? Now, we need to look at this almost backwards. Okay, now let's look at each number. 1 just gets locked up. 2 gets locked and then unlocked. So if we take a look, 1 gets locked up by 1 and that's it. And cell number 2 gets locked up by 1 and unlocked by 2. Warden cell number 3 gets locked by 1, unlocked by 3. Number 4 gets locked by 1, unlocked by 2, but then locked by 4. Now, the key thing about this is looking at the factors of the numbers. We discussed multiples when we were doing the problem, but the solution is buried in the number of factors of each number. And I'm going to write down the number of factors for each of these numbers above it. So, warden cell number 1 has 1 factor. 2 has 2 factors. 3 has 2 factors. 4 has 3 factors. 5 has 2. 6 has 4. 7 has 2. 8 has 4. 9 has 3, 10 has 4, 11 has 2, 12 has 1, 2, 3, 4, 5, 6, 13 has 2, 14 has 4, 15 has 4, and 16 has 1, 2, 3, 4, 5. Now, if we take a look here, every cell that has been unlocked, I'm going to draw a little circle around. That one's unlocked, that's unlocked. Oop, I made one mistake there, didn't I? Sorry. This number should be 2. Okay. So that is unlocked, that's unlocked, that's unlocked, unlocked. Now, every number that I have put a circle around there, you will notice, is an even number. Those that remain are all odd numbers. And those are the ones that are locked up at the end of the problem. And that's why. So it's all down to the number of factors and whether it is odd or even. So if it has an even number of factors, they're unlocked. If it has an odd number of factors, they're locked up. And that's what's special about square numbers. Square numbers have a number, a factor in the middle that you multiply by itself. You get 4 by doing 1 times 4 and 2 times 2. If we look at 16, 16 has lots of factors. 16 has 1 goes into it, 2 goes into it, 4 goes into it, 8 goes into it, 16 goes into it. 1 pairs up with 16, 2 pairs up with 8, but 4 pairs up with itself. And that's the reason why the square numbers are the ones that get locked up at the end of the problem.